Hi everyone, my name is Yitong. I'm an engineer from Arab, and I've been using Oasys Primer for the past few years now. So in today's webinar session, we're going to be talking about how to make design changes efficiently using Oasys Primer. So in our day-to-day task, we might be required to make changes to entities, and not just one single entity, but many entities at once. So Oasys Primer provides a whole suite of tools which help all of us make these design changes efficiently. So a bit about today's webinar structure. First and foremost, we'll learn how to make changes to multiple entities at once by combining the use of the Quick Pick menu and also the Keyword Editor tool. At the same time, when we're making lots of changes to our models, it's imperative that we check our models and fix them before running our analysis. So I'm going to give everyone some top tips of using the contour plots as well, how we can manipulate the data to use that and check and fix our models. Sometimes making design changes to our model means that we might want to bring new parts into our model or bring entities across different models. So Oasys Primer has a clipboard tool, which is a really powerful to use to transfer data across models efficiently. So we'll be going through that together as well. And before jumping into a live Q&A session, we'll be exploring the power of the part table too. So I'm going to be talking about the difference or when one might choose to use the part table or the keyword editor as well, because the part table, it's a powerful tool that could not just interrogate and update model entities, but it's able to sort of like give more information such as part masses, sum of all the part masses, time steps, etc. So often in our day-to-day design task, we'll be tasked to make a lot of changes to many entities at once. So if you're trying to change parameters on a series of entities, it can be quite time consuming. And the keyword editor is a great tool which can help you do this efficiently. Combining this together with the quick pick menus, you could change a lot of parameters of entities all in one go together. A few other functions of the keyword editor, as written over here. You can use the keyword editor to move entities across different include files easily, or just isolating a bunch of entities on the screen. So all of these will be showing with some demonstration today. So before jumping into the demonstration, just a bit of terminologies on our keyword editor. So on the top over here in orange, we can see that's the surfaces. So toggling on any of these would either show or hide different surfaces. And then at the top right, just like every other menu in the LS-DYNA panels, you would find a K over here, which when you press it, it opens up to the shortcut of a keyword manual to the exact page that you're looking for. And going downwards, you can see in red, this is what we call the acronym, the headers. So if you're ever unsure, instead of just pressing the keyword manual, what you could also do, for example, if you're unsure of what a PID is, you could just hover over it in Oasys Primer, and you show you a bit more information about what those acronyms mean. Going down further, you can see here in blue, this is what we call an entry row. So depending on whether you're opening a part keyword editor, a shell keyword editor, so on and so forth, by pressing on, by using the entry row, this is where you can add new entities to your current model. Going down a bit more as well, we have in green, this is what we call the data rows. So all of the available entities in your model are all inside the data row. So you can see that this model essentially has many parts altogether. As you can see, it's a part keyword editor. So now we're going to be jumping into Oasys Primer for a demonstration. We're going to be working through two exercises, one focusing more of shell entities, the second one focusing more on materials. But essentially, you could use the keyword editor for any types of entities. I'm just using two different entities so that to show you the different functions available. So let's jump into Oasys Primer. So I have a really simple extrusion model over here. The first thing I'm going to do is I'm going to use the contour bar at the bottom, which we'll talk about in a bit more detail later as well. If you press on here, you can toggle different contour plots. And what I'm interested in right now is to look at the shell thickness of this particular part. So if I press on shell thickness, you can see it changes, and I can press on SI to get a shaded image view. So we can now see that the whole extrusion has a constant shell thickness of 2 mil. And the reason because of that is because if I edit the part and edit the section ID quoted by the part, you can see that all 4 nodes of the part are quoting a 2 mil thickness. So in day-to-day design changes, we might need to have studies where we sort of like varying the shell thicknesses to see the effects of that on your vehicle crash test, for example. So perhaps one of the studies that we want to do might be we want to change the back wall over here, the shell thicknesses to 3 mil. So we could do that. We don't have to actually put those particular elements into a new part. We could introduce thickness to the shell entities, because if we introduce thicknesses to those particular shell entities, what that means is that those shell thicknesses would trump the shell thickness quoted by the section ID. So repeating that if in case that was unclear, if an element doesn't have shell thicknesses defined in its element, that means the thickness will be quoted by the part section. If the element has thicknesses defined in them, then those thicknesses would trump that given in the shell section. So you can have one part, but you can have a lot of entities in one part, but they can be quoting different thicknesses. So let's jump into it. So in this model over here, these are the only shell entities that I have. I'm going to go back into a shaded view first. And then because we're interested in shell entities, I'm going to go into element, shell. Then using keyword here is how we open up the keyword editor. So what I'm going to do first is I want to get these particular entities that I'm interested in onto our keyword editor. I'm going to expand this out a little bit more. So how do we do that is currently the keyword editor has all of the shell elements, but we want to isolate it using the options button. So if we press options and select, this gives us sort of like more options on how we can select entities. So I can pick them one by one, but that's a little bit inefficient. So we're going to go into the sort of like quick pick tools that we have in Primer. What I'm going to do is because I'm going to select the wall elements at the back, I'm going to use a feature line selection over here with a 20 degrees defined angle. And I'm going to select, by selecting one of these, you can see that all of the rest of the wall elements are selected. I can do the same to the one at the bottom as well. You can see now I've gotten all of the elements that I wanted easily. So you can look at the screen, double check, are these all the elements that you want? Are you happy with these? Before you click apply. So now when you press apply, it doesn't directly reflect into your keyword editor. So the elements that you picked, they are stored. But what you need to do to get these elements isolated onto the keyword editor is now press options and then press only selected. So then it only shows the elements that you've selected. And it also highlights them. If you don't want to do another double check, you can go to options, sketch selected. So you can double check on screen. Are these exactly the elements that I want to make changes to? Am I happy with them? If you are, then we can move on with them. So what we said we wanted to do is we want to introduce shell thicknesses to these particular elements over here. So how we can do that essentially is by adding a suffix. So you can see that all of these entities are highlighted at once. So what that means is that if we make the changes to one of these entities, this will also be reflected to all of the other entities. So to give a demonstration, if I toggle on suffix, and I'm going to choose this thickness suffix now. So if I press, you can see that instantly all of the other elements also has the thickness suffix turned on. So let's say I want to increase the thickness of these shell elements to 3 mil. I can just put the thickness in all 4 nodes as 3 mil. You can now see them reflected throughout all of the different entities. If we're happy with this, we can press update. So now let's go back to the contour view, and we can see very clearly that these particular elements are updated by um, to a shell thickness of 3 mil. So that's efficiently changing the thickness of multiple entities at once. So let's go back to a shaded view, and I'm going to open the keyword editor again. So now let's say I want to make changes to these particular entities further. What I could do to quickly isolate these particular entities on screen is I could essentially go to, remember we have the filter over on the top, which filters it by suffix, and I know it's the first suffix over here. So I could say that I want to toggle on all of the elements with thicknesses, and all of the elements without any suffixes, I don't want to see them. So now in your keyword editor, you can see that only the ones with thicknesses are quoted, and those are essentially the ones that we've just updated just now. So that's another way of filtering data easily. I can use options and then select all. So it selects everything on this table over here if I want to make any changes. Okay, so let's try something else again. So if I want to unselect all of these, I could press options and unselect all again. So you can imagine that let's say I select all again, and something that I could do as well is maybe if you want to quickly put in changes such as increasing the thickness by 20%, we could also do that in equation form. So we know that the current thickness is 3, so we can use equals 3 multiplied by 1.2. Through this, if you press enter immediately, you can see that all of these rows get reflected to 1.2 times 3, which is 3.6. So that's quite a useful tool. But at the same time, if I unselect all, let's say, for example, in thickness 2, these two are 4, and then the other elements are 3. So it doesn't make sense for us to write equals to 4 multiplied by 1.2, because what that means is that these other rows will be incorrectly updated. So that's a bit of a challenge over there. So what we could do, if let's say I can say like in thickness 3, this is 3, 4, 5, 6, 7. Another thing that we could do is if I select all, instead of equals to 3, I can use equals to the acronym thick 3 multiplied by 1.2. And now if I press enter, you can see that all of its original thicknesses are updated with a 20% increase. So that's a powerful tool if, let's say, all of your different um, all of your entity values are different over here. We can also talk about parameters. Sometimes you might want to use parameters to change the values easily. So we can add a parameter from here, param. So let's say I'm going to create a parameter over here, and let's just call it thickness. And I'm going to give this thickness a value of 5. So we now have created a simple parameter. Let's go back to our shell. So again, I'm going to toggle everything with thickness on. And let's say if I want to quote that parameter, it would just be and thickness. Cool. You can see that once I have a parameter over here, I can hover over my parameter to have a look at what the value it's quoting, and that's 5. So, but the thing is, you can imagine that if there's many parameters in the keyword editor, it becomes a little bit hard to hover over each of them individually to see what's the exact um, value they're quoting. But once you've entered a parameter into your keyword editor, you can see that there's an additional P which pops up over here. And once you click it, all the parameters will turn into the numbers that they quote. So that's quite an easier way to visualize the particular values. And if I press it again, it goes back to its parameter. Okay. And finally, let's say, for example, in this scenario, sometimes we might want to compare our CAE data with what we have in our CAD. So we might want to, for example, overlay coordinates in a different software. And that means that we would need to export the coordinates of all of these nodes available. We could use a keyword editor to easily export into CSV files as well. So because like the example I mentioned, if let's say we want to export nodal coordinates, so we'll definitely go back to node and let's look at the keyword editor for our nodes. So I can select all. So we know we want to export all of the nodes in our model. And if we right click on any one of these over here, you can see that there's an export file button. So I can just press an export file and I can choose whether I want to export it in keyword layout or single row layout, which we'll talk about a little bit more detail later, and then just export a CSV file by putting a file name. So that's it for the first exercise. The second exercise, we're going to jump into a materials keyword file to show you some other tools available in using the keyword editor. So I have my model 2 over here, which essentially is just a model with a lot of different materials. So if I go to Mat, and I'm going to press on keyword now to open up the keyword editor. So the first thing we can see is that it's really messy. It's really hard to see different things. The reason is because when you have a lot of different types of materials inside your model, all of them would have different optional cards. So you have many, many different optional cards available. So when viewed inside a keyword format, it might not be the easiest way to compare different materials together. These are the type of situations where I might prefer a single row format, for example. So you can see every single row it aligns itself into one single material. So I think that's a little bit better. And we could also go a bit further from here as well, such as if we know the only things that we want to compare are just the titles and also, for example, the densities of the materials, that means we only need card 1 and card 2. We don't really need all the other optional cards. And we could collapse all of those rows by pressing on the numbers on top, collapsing card 3, 4, 5, and so on and so forth. And we can see that makes our keyword editor even cleaner. And one more thing that you can do in Oasys Primer 21 and above, there's this new button over here called Auto Fit Columns. And when you press that, we can see that it scales all of the different columns much, much nicely. So you can see everything together at once. If you don't want to use the auto fit, you could also just like manually drag them or just double click on them to auto fit it. You can reset it and auto fit it again. So, an easier way to compare as well is if we press on the tops of these acronyms, it arranges everything in either ascending or descending order. So if I press on surfaces, for example, we can see that it arranges all the material types from type 1 all the way to type 126 and so on and so forth. If I want to compare, let's say, densities as well, I could do that easily. I can just press on density over here. It groups everything in terms of ascending order. So what that means is that if I want to select a particular bunch of entities, let's say these materials over here, I could just press here, scroll down to where it ends, press Shift on my keyboard, and left click on my mouse again. And then I can make changes together at once. So just like how we did just now. So something like that. So the next thing I want to show is how to use the keyword editor to isolate things on screen. So I think in this scenario, maybe I'll go to a model where I actually have entities other than materials on the screen. So let's go to maybe like a full model as such. So let's try that. So I'm going to go back to a material keyword, make the similar changes again, make it cleaner, fitting it. All right. So for example, just now we arranged it by the densities. So again, I could isolate things like that, choosing the same densities. And then if I right click over here, you can see that I have some options. I could press only so that it shows only things with these materials on the screen. And that allows us to like isolate things easily or have a visual approach to check things as well. Or let's say I want to move all of these materials into another include file. I can easily do that from the keyword editor as well, because keyword editor allows us to just make changes to many entities at once. So I could press on include over here, either one of them, and it brings up this panel. So I could browse and then choose the include file that I want to move it to. So if I want to move it to body in white, then I can just press body in white. Beware of material only and find reference items as well. If you click apply by using material only, that means we're just moving all of the material keyword cards into the new include file. But find reference items before applying allows you to bring things such as defined curves as well, which are the stress strain curves, for example, quoted by each of the materials into the new include file too. So that might be an option that you prefer as well. Do that once more. Okay, so imagine like we've made changes to like certain materials out of all of them. Um, Sometimes if your model is really large with a lot of materials or parts or whichever entities, when you press an update on the keyword editor, it would do checks on all of the every single entity at once, which might take a little while. So we want to make sure that before we press update, we're confident in the values that we put in, there's no errors and so on and so forth. So let's say, for example, if we've only made changes to the different highlighted materials over here, we could also just quickly do a quick check on these before we update by clicking on right click and then press check over here. So that gives out like primer sort of like checks to make sure that you're happy with the material, and if there's any errors, warnings, we can check that again as well, make changes before we press update. That way we can ensure that when we press update, we're confident that all of the materials that we have are without any errors. If we want to open up things on the keyword editor quickly through the visually as well, we could do that. So for example, if I isolate the bonnet on the screen and I want to get all of the parts into a keyword editor, I could just right click and drag a box, and instantly you should be able to find a keyword menu over here. And that puts everything into a part keyword editor. If I do the same for a quick pick material, same thing, drag a box, keyword, and that opens up the material keyword editor. So that's another function of using the quick pick menu and the keyword editor together. So lastly, before I end the topic of keyword editor, let's show some shortcuts that might be helpful for everyone's day-to-day tasks as well. So we might have already talked about some of the shortcuts. So the first one, maybe if I go back to shell, it will show that a little bit better. If I expand this out. So if we middle click on the down button, it goes down by steps of 10. So if we want to scroll through entities quicker, we can do that. Or if you use the right click button, this skips it by 100. So it goes down by, the values go down by 100 as seen. already talked about auto fitting. If we double click on each of these as well, it auto fits it immediately. And maybe using the material keyword, I can show some other useful shortcuts easily too. They have longer titles. So I'm going to auto fit it. And let's say my mouse is over here. If I press Control A on my keyboard, that instantly selects everything. If I use a triple mouse click, that does the same thing. Double mouse click allows me to select strings together at once. Okay. If my mouse is here, if I press on my keyboard Shift and left and keep pressing left, that highlights the alphabets to the left and right. If I press Shift up and down, that highlights everything to the left or everything to the right. So how about if we use Control and Shift together at the same time? So Control and Shift, it basically does the same thing, which is you're highlighting, but in terms of like strings together. So these are just some shortcuts which might help when you're using the keyword editor too. And I'll have them on the screen so that everyone can have a look or take a screenshot if desired. So now that we're done with the keyword editor, we can move on to the next part of our learning bus, which talks about making changes using the contour plot. So contour plots work in a similar manner as a keyword editor, where all the values of entities can be arranged in ascending order. Apologies, you can ignore the descending, it should just be arranged in ascending order. So in this section, we'll highlight some tips and tricks to use the contour plot to make day-to-day tasks more efficient in a more visual approach using the contour plots. So let's go back to Primer. So the contour plots we showed a little bit before down here. And it's a good way to visually check things and isolate things, I find, in a more visual approach. Because we can imagine that if, let's say, we have a full model update and we've made like many changes to all the materials, all of the thicknesses, and so on and so forth, it becomes a bit hard to pinpoint the changes using a keyword editor. And a more visual approach will make us allow us to check easier or spot any mistakes easier as well. So very quickly, what I mean is, for example, if let's say we wanted to quickly check the shell thicknesses of all of these parts, we could do that as well by just pressing SI, and it brings everything as a contour. So we can move this around. We can do a quick check. We know that in most parts, the sort of the the vehicle is meant to be like symmetrical to each other. So we'll have a look at this. If we're happy with it, it looks all right. So we can go on to the next check. And the other things that I can do is, for example, I want to check material properties. I could also check like the yield stress to make sure that each of these materials are quoted correctly. I can press yield stress that updates the contour plot, and again, use a visual approach to quickly check. And this is when I realized that potentially there's an error over here, because we could see that both of these, they have a different color contour. That means they have different yield stresses, whereas we think that they might be the same because these fenders are meant to be symmetrical. So I could quickly go onto the quick pick menu, choose a material, and then let's have a check between both of them. So the first one and the second one. Then immediately I can see that something has gone wrong over here, because this part quotes a windshield material, and we know that it shouldn't. Windshields, those are fender parts. So we could then quickly just go back to part, edit this part, and make sure that it's quoting this right material by picking on the other left-hand side fender. Update. You can see now the contour plot has also been updated. So that's a very quick way to check our model and then subsequently make changes to it. So you can have an explore around. It has a lot of useful things inside the contour plot. For example, if you want to have a look at um, element formulations, the number of integration points, just a check before running your models. Um, I think these would help speed up the process of checking for errors much quicker. One other thing that I like to do with the contour plot a lot as well is checking element quality, because other than just allowing us to sort of look at things in the visual approach, we can also use the contour plot to pinpoint particular entities as well. So to go for an example, let's plot minimum length element quality. And then I'm gonna reset this to auto. Apologies. Okay, so now this shows all of the minimum element lengths of all of the elements available in the model. So first thing I can see is that in the contour bar, it shows from the minimum element value to the maximum value. So there's what it's saying over here is that there is a element that has a minimum length of 0.06 mil. Um, and that sort of like strikes me immediately as something that might potentially be an error. So what we could do over here is we can right click on the particular band and we can say that we want to display just items in this band. If I press it, we can see now it only shows at everything in the dark blue band. So it might still be a bit hard to pinpoint which exact elements are causing the issues. So there's a lot of spot welts here, which maybe you're okay with, or adhesive that you're okay with the element quality. So maybe we want to narrow this band a bit further because 0.06 to 1.77 might be a bit too large. So what we could do is we could also adjust this band a bit more. So if I press on right click and then let's press on settings, this gives us more options on the contour bar. So we can see over here that the minimum and maximum value is set as auto based on what's available on the screen and your model. Let's change that. So I want to say I want to plot a minimum value of 0 to a maximum value of 0.25. It gives you options as well and of elements below and above a band. I will choose to not draw them. And there's also, let's update this first to have a look. You can see then it shows all of the different elements um, from 0 to 0.25. Um, I can also press disable discrete contouring and update again. Then it shows everything as 0 to 0.25 without those discrete contouring based on the elements available. I'm going to untick that again to show everyone that. So now this gives us more sort of a clarity on what's going on. So now we could say, let's say I want to right click this and then display items in this particular band. I'm going to press A on my keyboard to auto scale that zooms into one particular element. Instantly, then I can see that something's gone wrong over here. We, there might be a there might be a node which is essentially wrongly placed. This should just probably be a three-noded element, but we have a fourth node over here, making it a very small element length. So now that we've identified this part over here, I can right-click and only this part. Okay, and then let's go back to a shaded view. So turning on the mesh, we could see clearly something's gone wrong over here. So we could easily fix this by using a node merge. So if I go into node, Primer has a node merge function, allowing you to select the nodes, review the merge, and then merge these nodes together, and then fix this. And now if you press element quality, I can reset um, to auto, and then now you can see that the 0.06 disappears. So there's another 0.08, but we can investigate that a bit further as well. So this is just some ways the contour plot is able to make your day-to-day checking lives a bit more efficient. So you can use the contour plot to make checks, and then by adjusting the band, also isolate stuff, make changes easily. And that's it for contour bands. So that's a particular shorter one. And then the next part we're going to go into is the clipboard. So we talked about these, and let's talk about the clipboard. So Clipboard is another tool and that we can use to make changes easily to many entities. And the difference, particular between keyboard and keyword clipboard and the keyword editor, I like to think about it is that the keyword editor allows you to make changes on many entities, but they must be of the same type. So you're making changes to a lot of parts together, a lot of materials together, for example. Whereas the clipboard allows you to make changes to a lot of different entities. So you can make it to part, suction, material, all in one package in one go. And that's uh, why the clipboard is quite a powerful tool as well in comparison. So going back here, so there we can easily, let me close down some tabs first. We can easily see the clipboard up here. So I'm going to press on it. So there's some things that we're going to focus on over here. So on the right hand side, these are all of the different entities that's available. And we could choose to add the different entities into the clipboard. So if I press add, let's say I'm just adding a part. I can add part and then click on here, this part, and add items. Now we could immediately see that the one part has been added to the keyword editor, sorry, the clipboard. So another useful tool over here is find reference items. So when we were talking about the keyword editor, we talked about find reference items a little bit. So if when we use the example of a material, it finds what curves that it's referencing as well. Um, if we choose a part, something similar happens. So we can think about the part, it will reference sections as well, materials as well, and then there are things which are referencing the part. So like shells as well. In this particular part, you have shells referencing that part. So if I press find reference items, you can see all of these different items are chosen and added to your clipboard at once. But that's not the only way that we can add things to our clipboard. We could also add things to our clipboard by using the quick pick menu. So from blank, I can change this as well to clipboard add. So that means, for example, if I'm pressing different things, I'm essentially adding parts to my keyboard. You can see that I've picked these. And if I go back to my clipboard now, you can see the number of parts then increases based on what I've chosen. Or you could also just remove things from a clipboard here. So why is the clipboard important as well? Is you can imagine if you want to make many changes or operations into a single part in your model. So you want to do some orienting and then some blanking and so on and so forth. And there, if we use the clipboard, then all of these things that you've chosen will be saved, and you could create operations on them um, easily. You don't have to keep clicking on them again. What I mean by this is, for you, let's use the example of an orient. So in the entities that I've chosen, if I go back to orient, so this gives me like a pick menu, right? That allows me to pick what items I want to orient. And if I press on, for example, part, then it gives me the options instead of just picking parts from here or from the screen. We can see that there's also a row over here called clipboard. So what that means is that if I click on this, it will orient all of the parts that I've chosen on my clipboard. So the clipboard is sort of like a save menu. So if I click this, that means all of these parts are selected and I can perform functions on them. So then if I finish with my orient, I can do another function if I want. And then if I want to make selections, the entities from the clipboard will still be saved. So like I mentioned, we know we want to make a lot of different operations at once, then we can use the clipboard. Okay. And then If we press options over here, you can see that there's also the options of add to clipboard, remove from clipboard. So that means that when you're performing different operations and you start adding things and you say that you think about like, oh, actually, I want these things to be added to my clipboard as well. We can just press the options button and just click on add to clipboard, and these will automatically be added to your clipboard as well. So one more thing to be aware of for the clipboard before we jump into an exercise is find reference items. So just be aware of using find reference items. For example, if you select the shell element, the shell references a node. So when we use find reference items, the nodes would instantly be chosen in your clipboard as well. But if you chose a node, um, and you press find reference items, that doesn't mean that the shell elements would be um, added to your clipboard because the shell references nodes, but the nodes do not reference the shells. Nodes are referenced by the shells. So just beware as well when you're sort of like adding things to your clipboard and then using find reference items. We can see that on the right hand side of the clipboard, we've shown that you could check what entities are available inside your your clipboard. So just have a quick check as well. Make sure that what you're expected to be added when using find reference items is actually added to your clipboard before performing any other functions. You can see that in the clipboard, there's also a tool called move to include file. So similar to that of your keyword editor, you can also use the clipboard to move things into different include files as well. And this gives you a bit more flexibility of moving different entities together as well. But similar to the keyword editor, we also have the find reference items function. So maybe from here, we could try out a little exercise on the clipboard. So let me jump back to the slides. So we're going to try using the clipboard now to add new parts into the full model. So we're talking about, in this Learning Buzz Part 2, we're talking about making changes. So instead of just making changes to existing parts, a lot of our day-to-day tasks will also bring in new parts as well. So that's what we're going to use the clipboard to do easily. So I have an example over here where we have two new parts. You can see on the left, there's a fuel tank cover. They are meshed, and we want to add that to the full model. And we want to add it to a particular include file in the full model as well. So the clipboard is a powerful tool for us to add new parts into a model. That's what we're going to show right now through a demonstration session. Okay, so going into the next exercise, we can see that this is our full model over here, and we don't have the fuel tank cover as mentioned. Toggle to the next model. This is essentially the new parts that we've meshed and we want to add it to the model. Press J. You can see that these parts are also connected with nodal rigid bodies. J is a shortcut for attached. So that means that other than just bringing in the parts, the shells, we also want to bring in the nodal rigid bodies together. So that's bear that in mind. I can view again all of these, everything that's inside here through the part tree. Press content, then we can see that there's some elements, shells, the notes in over here, two parts, and of course the sections that's quoted by the parts. We also have the constrained nodal rigid bodies, 57 of them, and 57 set nodes, because each of these constrained nodal rigid bodies references a set node. Okay, so we mentioned that we want to use the clipboard to add these things. So let's go into the clipboard now. So let's add the part first. So we want to add these two parts, them, and I can use find reference items. So we can see that, okay, the sections, the shells, the nodes, they're carried forward. That's good. But we haven't added the nodal rigid bodies or the set nodes as well. So let's add those. Say if we add nodal rigid body, and we can select all of them. Then, because we've selected the nodal rigid body, we can use find reference items to also find the set nodes which are being referenced. So everything on the right checks out here. It seems like we've selected all that we want from the model. And then if we're happy, let's bring this to the other model. So if we look into the different options over here, we could see an option here called merge into model. Let's press into that. So when you press into merge into model, first thing is that they ask you which model do we want to merge it into. So I can say that I want to merge it to model 4. Okay. And then it gives you the options to choose whether we want to add the things in the clipboard contents only, or do we want to just take the notes and elements, or use another find reference items. So we know we don't need find reference items right now because we've already used find reference items before. So we're happy with all we have in the clipboard contents. So we could just add everything in the clipboard contents and press apply. This brings out another menu over here, which I'll carry out. So again, going from the top down, it says that model 4 is the primary model, okay? And then model 0 essentially means these new parts that we want. We're calling it the secondary model. It's gonna add, it's gonna put these together and bring it into a target model called model 6. And it gives you a title. So you can change the title if we want. Okay. If you're going down a bit more, you can see destination include. By default, you add it to the master file of model 4. So because we've mentioned we want to put it into the particular field tank include file, we can change that as well. So let's select, and we want to bring it into the field tank include file. Okay, so before pressing apply, we need to fix those clashes first. So what I'll do is I'll click increment secondary model items on clash. So that means that the secondary model is this particular model on the screen. If there are any clashes, I'm just gonna increment the entity numbering. I'm fine with that as well because I'll show everyone that once we bring everything in, we can then use the renumber tool, which we've shown in part 1, to easily renumber these entities into the right range. So now when there's no problems with any clashes, we can then press apply merge. So now Primer is merging these two models together. So we know that these merge parts, merge models are in model 6 now. So if I just have model 6 on the screen, we can see that the field tank cover has been added. If I right click on the part and edit it, we can see that because we've chosen to add it to the field tank include file, these entities are added to the right include file. So this is how we can easily add new parts into existing models or existing include files. So there's one last thing which I talked about in terms of numbering. So if we go into model renumber, and let's use the renumber includes table over here. So we can see that not everything in the field tank is in range. And this is because we brought in new parts, new entities from another model. And there were clashes when we brought it in, and Primer essentially just puts it into a numbering range which has no clashes. So now we could just right click on no and press renumber into range. So now all of those new entities that we added have been renumbered into the range easily. And then we can click apply. That's how to efficiently add new parts into an existing model. So I think I have one more slide over here. We do have a webinar on our YouTube channel as well, and talking about the clipboard in more detail. So I'll leave the link over here as well, so that if we want to learn more about the clipboard, please feel free to watch the comprehensive video linked. So we're down to the last part of this session, which is the part table. So we talked about making changes with the part table, with the clipboard, the keyword editor, contour plots. Part table is another versatile tool as well we can use to make many changes at once. And what's different between using a part table and also the keyword editor is, let's go back to Primer. Maybe Primer, we can show this better in a demonstration. So I'm going to choose, again, some parts like here. So if I use a part keyword, then I'm going to select these parts, only selected, and single row format. So each of these parts, we could see the part ID, the section ID, and the material ID, which makes sense because these are the things quoted inside your part keyword card. But it's a bit hard for us to also have um, the thicknesses or the material densities and things like that together in one table, because that might be useful for us to know the different part IDs and also the section thicknesses that they quote. Um, so the part table gives us a bit more flexibility into that. The part table is able to expand these columns as well so that we can see together with the part ID what's inside the section ID, such as the thicknesses, and what's inside the material ID, such as the densities. So I can show that in a bit detail if I open up the part table. So part keyword editor is here. Part table is in the same place inside parts. So we can press table. And I want to get all of the visible parts inside the table. So there's different options. I can either choose it from the table over here, drag on the screen, use a visualize filter, or I could just say I want all the visible parts. So I'll press this. That essentially brings out what we call the part table. So a bit similar, but a bit compared to the keyword editor. But we can see there's a bit more things inside here as well. We have the part IDs, we have the section IDs, the material IDs. But then we can see that the section gauge has also been added over here. So it's quite a nice comparison. We can compare part ID together with their section gauges, um, listing them in ascending order, descending orders, and making changes easily to a bunch of them as well, just like when we use a keyword editor. Okay, so the part table also gives you many, many more options on what we want to put on this table. And you can find all those options by pressing View. So certain things that we've mentioned about, such as the material type and material yield strength, um, the material density, that's what we mentioned. We can toggle this on, and we can see that that's been added to the table as well. So it gives a very, very good comparison on the different parts that you want, part IDs that you want, and their section section um, definitions as well, and material definitions. I could also untick things. So if I don't want the part title, I don't want the type of the part, I can untick that as well. Again, we could arrange things by ascending, descending order, highlight things, making changes to many things at once. On top of that, let's say I'll use the part table again, but I'll choose all parts in this model over here, which is active. So it brings out all of the parts in this model. Other things that I could do with the part table as well is it can calculate masses really well. So I can calculate masses, DYNA added masses as well. So it also shows the masses of each of the different components over here. We can arrange them in ascending, descending order. On the top, it also adds up all of the component masses together. So very quickly, we can see what's the mass of the model. How much mass is DYNA adding as well? It's shown over here. And this is a good way to find out if there's any parts which is causing a lot of added mass. We can select the first view, right click, uh, maybe right click on the part ID only to show which exact parts are causing um, the high added mass. And then if we want to see, okay, is that because of the element size, smallest element, we could do that as well. Or we want to check what is it? The L form as well, we can check that potentially just to give us a bit more understanding of all these differences together in one table. And that's the usefulness of a part table. It puts everything together into one table easily. Okay, we can make certain changes easily as well. So we've already mentioned that we can change things such as the density easily. No, maybe not the density. The section gauges easily by putting in numbers. If we view part names as well, let's try to bring part names in if I can find it. Title, where is it? It's okay, I've lost that. Maybe mat title would do. Showing everyone certain functions that you can do. Okay, let's try to open this again. Apologies. Finally. All right, part title. Apologies for that. So I could sort things by part title, and something else you could do with part title as well is there's like a find and replace function. So if we right click on part title, we can see that there's find, replace, and title as well. So it essentially allows you to look through everything and replace the part titles easily in one click of a button. Um, you can also have the write function on part table. So it gives you more flexibility of bringing it out into a CSV file, making more comparisons. And before you write out things in like a CSV files, you can also just arrange your title, arrange your table, clean up things that you want, clean up things that you don't want. For example, um, make sure that you get the just the parts that you want before you click write. So a lot of flexibility there, which is given. Essentially, in a nutshell, so that's the usefulness of the part table. It gives you more comparison, comparing the part and also things inside the sections, inside the material cards, gives more information about the elements, the masses, and so on and so forth into one big table together. So that should be the end of today's session. We talked about the keyword editor, we talked about the clipboard, we talked about the contour parts, and we talked about the part table, all useful tools to make changes efficiently in our data diary design. So thank you for watching. So to stay up to date with us, feel free to subscribe to our newsletter or visit any of these links above.